See ya.
See you later. I feel like you guys are earlier today. Maybe I'm running late.
I don't even know what's the rule? I don't even know the rules. I don't know about that though. I secant equals like tan times secant.
I should run to a 6.
you? Want me to just-
How you build from here.
I think you have to factor this in.
Okay, I factored it
Wait, what is it?
Yeah, no, I definitely
Whatever I do, you guys make it comments, and I can put it all in. And then when you, yeah, when you just
Was there,
this one, it becomes like you
like the calculator work circuit was there, so that let's do.
And then it's just
I submitted,
because, for that, so when you're multiplying them, but because this is like subtraction.
on the 8th question. So, to on the 8th question.
98.
Well, we just
There was some
updated
fast.
I got a 99.
So like this
Yeah.
is-
So, like, these are
I
just.
I started with a 86. We got boosted to 93 from the curve, and then got 5 extra.
Morning, FHS. Today is Tuesday, September 19th, 2023. Please join me in a minute of silence.
Guys, please be quiet for a minute of silence.
Yeah, I don't know why she was punched, but she just gave it.
Mason. What did I just say?
What?
What did I just say? I asked you to please be quiet during minute of silence. You're not listening to me, so you didn't hear it.
Please stand if you are able and join me in the pledge. I pledge allegiance to the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you.
I did it yesterday.
All right, first thing is last chance for full points on the assignment I asked you to turn into Google Classroom. So I suggested you do that during class last time, but if you didn't have time to do it during class, you could have done it for homework. But if you forgot, or your internet wasn't working, or you had any issues with Google, you can still turn it in now with your name on it, but this is your last chance for full points. So any others that I did not get in Google Classroom? Number 24, the circuit over Power World. That's from 2 classes ago. Okay, then the 2 handouts you guys picked up today are 28 and 29. So this isn't necessarily a long lesson, but it is an important lesson. Of everything we do first semester, I would say this is probably the most important. And it's the last big topic before we get to our test. And that is the chain rule. So we're going to talk about it generally on our notes here. Then the second page has 15 problems. I'm going to ask us to do 10 of those. There's a couple that you just can't do yet. There's a couple that you have to have memorized that I haven't had you memorize. And then finally finish off with 2 Khan Academy assignments over chain rule. But it is a pretty short one, even with all of that. Yesterday, some people were finishing with like 30 minutes left. So, all right, first thing you guys need to know about chain rule is that chain rule is not a different type of differentiation. It's in addition to what you've already done. So now when you use the power rule, sometimes you have to ask yourself, do I need to use the chain rule also? You use the product rule, you have to question whether you should use the chain rule. You use the quotient rule, you have to question whether you should use the chain rule. Pretty much the only time you don't have to use the chain rule is if you can just type it in your calculator. If you have a calculator and it's allowed and you do the derivative that way, it'll take care of the chain rule. But after every question you guys have seen up to this point has been rigged to where chain rule was not needed. But after today, pretty much the whole rest of the year, you're going to see chain rule every day, if not maybe once a week second semester. But first semester it's going to be pretty much every day. Okay, so chain rule is needed when you want to take the derivative of a composite function. So that's when you have a function. Okay, this is late now. That's why I asked for it before. Start turning it in Google Classroom then. Okay, so when you have a function plugged into another function. So the first example here, this is kind of a silly one to do it on, but I need you to see that why it's needed with an example that we can do by hand pretty easily. So if I look at this big picture here and try to take the derivative of this, I can still try to use the power rule. So I can bring the power down and then lower the power by 1. But because there's an inside function plugged in here, this isn't just x, it's an x cubed, that doesn't work. So write that, but put an x through it. To convince you that that's not the correct derivative, if we rewrote this with exponent rules, same exact question, we could bring the power down and lower the power by 1. That is the correct derivative. So you can see these two are wildly different. This inner function was just an x, and something about that makes it where you don't need chain rule, whereas x to the third you do need chain rule. Okay, so how should we go about looking at this one with chain rule then? So you need to start to identify what is the outer and inner function. So if I'm looking at the big picture here, I've got something squared. I don't want to use x because I don't want to confuse it with the other part. But the big picture is I've got something squared, and the thing that's getting plugged into the something is x cubed. So x cubed is the inner piece, is getting plugged into the outer piece, which is something squared. Okay, these 3 steps are verbally how we process chain rule. And it is a little wordy here, and it's actually quite a bit easier once you see a few practice questions. But the chain rule says you need to take the derivative of the outer part. So if I take the derivative of this, I'm going to bring the power down, lower the power by 1, but with the inner part plugged in. So instead of saying u, we're going to leave the inner function plugged in. So I'm still doing power rule. I'm just thinking big picture for a second. Bring the power down, lower the power by 1. But then the other piece, so that this ends up being correct, is we need the derivative of the inner function. So the derivative of x cubed would be 3x squared. And then chain rule says if you multiply these two, you would get 6x to the 5th. And we could see, again, with this real basic example, we know that that should be correct. So I'm going to start phrasing it that way to try to just kind of hammer in what we're doing here. We're doing the derivative of the big picture, the outer part, with the inner part just plugged in. Then we take the derivative of the inner function, multiply those two together, and then that's how you can find the derivative. So looking at this one, I would say the outer function is e to something. And what is the inner function there? What's being plugged into the something?
4x.
Okay, 4x. So chain rule says you've got to take the derivative of the outside part, and the derivative of e to something is e to something. Just like e to x is e to the x. But with the inner part plugged in. So go ahead and plug in the inner part. You also have to compute the derivative of the inner function. So the derivative of 4x is 4. And when you multiply these two things together, that's the derivative of e to the 4x. So the first step's a little harder to see because it's not just e to the x, but it's really the same process. The derivative of e to something is e to something. But chain rule says we have to come back and multiply by the derivative of the inside function. And in a way, I think that should make sense to you guys on this basic example here. Because if whatever number I'm plugging in for x, I'm multiplying by 4, it's moving along the x-axis 4 times faster, which is going to make the slope 4 times greater as well. So that's where this 4 ends up creating this 4. Okay, another way to say this, and you need to put a star by this because one of the two Khan Academies I'm asking you to do gives you tables only, and this is the easiest way to use this with tables. It's the same thing that I said on the last few questions, it's just in math notation instead of words. But this right here is the derivative of the outer function with the inner function plugged in times the derivative of the inner function. It's the same thing we did in the last two questions. Derivative of the outer function with the inner function plugged in times the derivative of the outer function. Okay, so here's this one that we did on the other side. Here's this one that we did on this side. You have to identify what's the inner and outer. Take the derivative of the inner of the outer with the inner plugged in. Take the derivative of the inner function, multiply those together. Identify the inner and outer function. Take the derivative of the outer function with the inner function plugged in. Take the derivative of the inner function, multiply those two together, and you get its derivative. So we're doing the same old power rule, product rule, quotient rule, but now every single time you have to ask yourself about chain rule and see if there's something else you can do. So when I look at this one, this is where it's going to be a little bit easier because it doesn't have to be as wordy now. I've got something to the 7th power. So how would we normally take the derivative of this? Okay, so that's the derivative of the outer, but I want with the inner function still plugged in. So that looks messier, but it's still the power rule. I brought the power down, lowered the power by 1. Don't change the inside part. And then the part that makes it chain rule is this, and I'm going to do this in purple in every question to help y'all see it. You've got to come back and then multiply by the derivative of the inside. All of that makes up the derivative. Okay, over here, we might want to rewrite this. So we can still do the first step the same way. Bring the power down. Don't worry about any simplifying right here. We can worry about simplifying another time. Bring the power down, lower the power by 1. If it was an x in the middle, leave it x. If it's an x squared minus 1 in the middle, leave it an x squared minus 1. But then chain rule says then multiply by the derivative of the inside. All of that makes up the derivative. Okay, so how do we normally take the derivative of sine? Okay, so if the derivative of sine something is cosine something, you're almost done. You just have to remember to take the derivative of the inside part. So it gets multiplied by 2. The derivative of secant something is, tangent is secant squared. I'm trying to give you the answer before the question. Okay, and then every single time, you think I'm overemphasizing it, but I'm not. If you do not train yourself to think about chain rule and remember to come back and multiply by the derivative of the inside, you will miss several questions on our next test. The other part is, if you forget the chain rule piece and you just do this, most times that's one of the wrong distractor answers in multiple choice. So you will still feel confident because your answer's there. But always multiply by the derivative of the inside. Otherwise, the rules stay the same. Okay, just real quick to show you why this is different than what we've done. Laura, you need to get your head up. Head up, please. So like when we took the derivative of this, we brought the power down, lowered the power by 1. Now technically we should have been thinking about chain rule, but every single question that you did was rigged where you don't need it. In this case, the inner function is x, and what's the derivative of x? And multiplying by 1 doesn't change anything, so we don't really need to think about chain rule there. So every question you've seen up to that point, the chain rule was always 1, so it didn't impact your answer. But now moving forward, that's not the case. Okay, slide over to the chain rule practice. And again, there's 15 questions here, and I'm asking you to do at least 10 of them. But try question 1 first, and I will go over it once I think you've had time to try it. That way we can make corrections if need be. Okay, and again, don't worry about simplifying it all here. You guys can worry about simplifying on the Khan Academy when you have to. Okay, so the first step of this shouldn't be any harder. It just looks more confusing. You're going to bring the power down, lower the power by 1. That's still the same power rule. I'm not changing power rule. But before you move on, you have to consider the derivative of the inside. If the derivative of the inside is 1, then you don't have to write it because timesing 1 doesn't change anything. But if the derivative of the inside is something else, like 12x plus 7, you have to multiply all of that together. This is the derivative of the outside with the inside plugged in times the derivative of the inside. And again, don't worry about simplifying it. There's not much you could do there anyway. Okay, questions about number 1? Okay, go ahead and keep going then. Try question 2 and 3 before you try any others. And again, just for focus here, don't simplify at all. Just do power rule, product rule, quotient rule, and then multiply by the chain rule. Again, you can work at your own pace here, but just make sure that you check back in with me when I go over 2 and 3. Don't just assume that they're right. That should have been way more than enough time, because number 2 should have been power rule, bring the power down, lower the power by 1, and now we've talked about chain rule. You've got to consider the derivative of the inside. If the derivative of the inside is not 1, you have to come back and multiply by it. So times 8t minus 3. All of that has to be your answer. Chain rule step is always going to be in red on this page. Okay, question 3. We could bring the power down, lower the power by 1. That's the same power rule, but then because the derivative of the inside is not 1, we need to multiply by the derivative of the inside before we get our full answer. It's not that the last step is hard, but for a few weeks it's hard for y'all to make yourself check it every single question. Okay, anything about 2 or 3 you want to ask before you keep going? Okay, try 4, 5, and 6 before you try any of the others. Again, once you have 10 done that you're sure correct from what I go over on the board, then that's good enough for now. But like, you should not know how to do number 10, and you probably haven't memorized how to do number 9. So those would probably be a couple worth skipping. Bless you. Okay, is that long enough for all 3 of them? Does anybody need more time there? Okay, to do the big picture part of number 4, you do have to have this one memorized. So if you don't have it memorized, you better have it memorized by next week when we get to our next test. The derivative of cosecant something is negative cosecant of the something and cotangent. Is that correct? I'm rusty on those. You do that on a test, you look at your answer choices, multiple choice, that answer is going to be there, and it's not correct because I didn't do what? And chain rule says I should multiply by the derivative of the inside, which is just 7. 7 times bigger. Okay, over here we've got 2 times sine of something, and the derivative of sine of something is cosine. So cosine of the something. Doesn't matter how messy the something is, just carry it along. Then chain rule says the something, the inner part, you need to come back and multiply by his derivative. So that would be 3 plus secant squared. Okay with that? Okay. And then once again, the derivative of tangent something is secant something. Secant squared, sorry. And then honestly, this is why chain rule is really easy once you kind of get over a hump. Once you've really trained yourself to check for the derivative, just multiply by 10. But students are often very inconsistent with remembering chain rule early in the year, but you got to get over that. Okay, anything more detailed about 4, 5, or 6 that you want me to go over? Yeah.
On 4, would it be wrong if you wrote like, instead of putting the 7W like in between each of them, you like cosecant times cotangent and then parentheses 7W? Do you know what I'm saying?
You said cosecant, cotangent, 7W like this? Yeah, mathematically this doesn't make sense because trig functions are only, like cosecant by himself doesn't mean anything. You have to say cosecant of an angle, like cosecant of what? So it's not, there's not a mathematical understanding of where you can like distribute these to combine them. So. Okay, anything else about 4, 5, or 6? Okay, then work whichever ones you want, but try at least 7 and 8 first. You're welcome to do 9 if you remember how to do, actually, you know what, I don't know if I even told you that one yet. You don't really need to know that one early in the year, so. Yep. They're not. That's why I'm going over some of them here. Well, part of it is 0 to any power would be 0, so why even write that? Okay. I'm not trying to rush y'all, but I am also just don't know where y'all are at. Do y'all need more time for 7 and 8? Say yes if it's yes. Okay. Then quickly check. So to take this derivative of a constant is 0. The derivative of e to something is still e to something. In this case, the thing being plugged in, the inner function is this stuff. So you had to come back and multiply by 4 plus 7t to the 6th. That was the derivative of the inside part. The thing being plugged into e to the x. Okay with that? Okay. The derivative of e to something is still e to something. But if that something's not just an x, where his derivative is 1, and multiplying by 1 doesn't change anything, we need to come back and multiply by the derivative of the inner function. And the derivative of 1 minus cosine x would be 0 minus negative sine x. Or 0 plus sine x, or just sine x. All of that mess multiplied together is the real derivative. Still good? Okay. Let's go ahead. Let's just do number 9 real quick, because I know some of y'all are curious about this one, and I'm not worried about you memorizing this yet. I will make it very clear before we throw it on a test. But to start this one, I just haven't told you how to deal with exponential functions like this. But I can use an example of one you know to help you understand what this derivative is. So just showing you a little bit early. So what is the derivative of e to the x? Okay. Well, not really. It's e to the x times the natural log of the base. But what is the natural log of e? So that's why we can get away with just saying e to the x. If you want the derivative of a different exponential function, you're still going to, just like this has a e to the x, a to the x is going to still be a to the x. But now we have to multiply by the natural log of the base. And if the base is not e, this doesn't go to 1, and so we have to keep up with that. So that's how you do the derivative of exponential functions. It's not hard, it's just slightly different. So for this one, I'm not asking you to practice it, you can just follow along with me. So just like e's a number, e to x stays e to the x times the natural log of e, 2 to something is going to stay to 2 to something times the natural log of 2. I'm trying to match it up with this one. The chain rule part would then say come back and multiply by the derivative of what's being plugged in there, which would be -6. This is just one that your AP exam probably will have one type of derivative like this, but as unimportant as it is, if we show it to you too early in the year, you just have to relearn it later in the year anyway. So, okay, nobody should be trying number 10 because I've not given you the derivative of inverse trig functions. Those are pretty low on our list. Usually I don't even show those to students until we get to AP review. So you just have to memorize a few things. Okay, next up, if you would try 11, 13 is a great question. And yeah, try 11 and 13 before you try the others. I'd say 13 is probably the one that I had the most questions about yesterday. So, but put down what you think you should do, and then we'll confirm whether it's right or not. Okay, so with 11 and 12 are kind of similar, so in case you forgot the derivative of natural log, I want to give you a reminder. The derivative of natural log of x is 1 over x, so the derivative of natural log of something is 1 over the something. And then the chain rule step, multiply by the derivative of the something, the inside part would be minus 10y plus 3y squared. Okay, any questions about 11? Okay, 13, even if you think you're doing well here, this is probably the one that you might have a mistake on. So to start off with his derivative, what is the derivative of sine something? Okay, cosine of the something. And then because of chain rule, I need to come back and multiply by 60 to the 5th. Over here, plus, with trig functions, when we square them, we like to put it right here, or raise them to a power. So this means sine x times 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 sine x 6 times. Or, just mathematically, this is the way we like to do it, but these two things mean the same thing. So to do this part correctly, you should have done the power rule. Bring the 6 down. Lowered the power by 1. So you can write it like this. Or like this. They mean the same thing. And is that it? Because there was an inside function on the second part too. Underneath the something to the 6th power, the something didn't have a derivative of 1. the something had a derivative of cosine x. So you need a chain rule for this step and chain rule for this step. You got to consider that every single turn. If that was just x to the 5th, then you would work it just like this and you wouldn't need chain rule. But it wasn't just x to the 5th, it was, or 6th, it was sine x to the 6th. Okay, and
When you're taking the derivative of like the second part of like the first, like you already did the first one, going to the second one, wouldn't it be cosine or does it stay sine?
this part,
Yes.
well, this part is still just the power rule. I said, if this has an exponent of 6, bring the power down, lower the power by 1. That doesn't change the inside at all. Then I worried about the derivative of the inside, which is where the cosine came from. But this is just like a more complicated looking power rule, but it's the same thing. Bring it down, lower the power by 1, but you're not changing what you're raising to that power. Okay, you should be pretty close to 10, but try these 3 with however many more you need to get to 10. If you need 2 more, pick the 2 you want. I'll go over all 3 of them, but okay, I'm going to work out 12 down here for a little bit more space. But the derivative of natural log of something is 1 over the something. It doesn't matter how complicated the something looks. It doesn't matter for the first step. It just carries down. But then you have to remember to take the derivative of the inside part. So the derivative of sine would be cosine. And the derivative of cotangent is negative cosecant squared. Of course, you have to have that memorized to be able to do it that quickly. But that's what you should get for 12. Number 14, I've got 7w to the 1/2. So the first thing I would do is bring the power down, lower the power by 1. Leave it 7w, I'm not doing anything with that. Then times the derivative of the inside, which would be times 7. And then what about this over here? What did y'all do with this? Okay, well, what's the derivative of e to something? E to something. And because of chain rule, I still needed to multiply by -1. Right, still need to multiply by -1. The derivative of negative w would be -1, just like negative x would be -1. Just a different variable, same thing. Okay, for 12, 14, or 15, any of those you've got more detailed questions on? Okay, so a couple things I hope that you feel about this at this point is chain rule is not any harder. It's one extra step, but every single time you take the derivative now, forever throughout calculus, you always have to question whether there was a derivative of the inside part, and if the derivative of the inside is not 1, you have to multiply by the derivative of the inside, otherwise your answer is not going to be there. And you have to 100% ingrain that in your head as part of your thought process. If it's a derivative question, whether it's power rule, product rule, or quotient rule, do the same stuff, but then before you move on, consider if you need to multiply by the derivative of the inside. Yes?
Can you do 15?
Did I not?
I don't think so.
Oh, sorry. I didn't mean to skip it. Okay, what's the derivative of 3z to the 7? Okay, do I need chain rule here? Well, the thing being raised to the 7th is just z, so the derivative of z would be 1. So we don't really need chain rule there because multiplying by 1 doesn't change anything. That's just like the ones you've been having. But this part, sorry, said I would color coordinate it. The derivative of sine something is cosine of the something, but then times the derivative of the inside, so times the 2z. Is that enough there? Okay, and not that you care at this point, but a big part of what we do in Unit 2 is chain rule. So really our last big hurdle in this unit is to practice it to where you don't forget to check it. Again, if you forget it on test day, then there's a handful of questions you're going to miss because of that, but it is important. But also after we take our next test in Unit 3, most of Unit 3 is over implicit differentiation and related rates. And those are really applications of chain rule as well. 4 or 5 years ago, I did a workshop with one of the guys that works with College Board quite a bit. And between chain rule questions like these, and then the chain rule that naturally occurs in implicit differentiation that you'll learn later, and the natural chain rule that occurs in related rates that you'll learn later, he approximated that about 25% of the points on your AP exam are chain rule. So a fourth of the AP exam is either questions like these or applications of these that you will see later. So very, very, very important. Most important thing we do first semester. Maybe not the most important thing we do all year, but probably the most important thing we do first semester. Okay, as long as you've got 10 of those done and correct, since I went over those with you, then that is good for number 29. Okay, and then the other two things I'd like you to do. Number 30, I've got 2 Khan Academies for you. The first one is usually a little bit easier for people. It's more like the ones we did on the worksheet. The second one has tables, and the first thing I'm going to ask you when you're doing the table questions, if it's not working out for you or you're trying to juggle a bunch in your head, I'm going to ask you to look at it this way on your notes, because it kind of pushes you in the direction of knowing what you need to look for out of the table. So, as I said, it is not necessarily a long lesson today, but it is important. So, you need to do those two. Put your scratch work on blank piece of paper number 30. And then I am asking for one more assignment to be turned into Google Classroom before I see you on Thursday. So please do that during class. If you do not have time to get to it during class, or for whatever reason you don't want to do it during class, then you need to put it in Google Classroom for as part of your homework. last thing we did last class, so product quotient rule. Double check. Doesn't matter. I got you. That makes sense. I can't remember who showed me hard copy. It's just that if you click turn in and you thought there was pictures attached and there weren't pictures attached, and then you figure it out after it's late, then you're gonna lose credit. So if I notice it before the due date, I try to say something so that you can fix it if that's the problem. But yeah, if I've already graded it by hand, I don't have to see it in Google Classroom. No, I just need either or. I don't need both. I've got 27. Are you still trying to figure out the numbers? I've got 27 as product quotient rule circuit, 26 as calculator circuit.
I just don't have that many versions of spreadsheet.
The 25?
Yeah.
Here's, I think I'd already graded yours in Google Classroom, so, just so you know, I don't have to have the one. That's fine, if you're ever unsure, I'd rather you turn it in, just to be safe. Make sure that you start turning these in Google Classroom, and it sounds like you need to organize language, so. I don't want that to keep happening to you. You already did them? You got the homework turned in? Let's see you next class. Take the agenda. There's something in Google Classroom that's due before class Thursday. I'm sorry? Okay, but you can still turn it in. If you don't turn it in now, you're just running the risk of forgetting. Bless you.
Did I do the first part correctly? So it's like doing the breakdown, so I just need to keep the original stuff and lower it to the line.
Yes.
Then we multiply
So now-
stuff.
First you need to put H.
Then how would you simplify that?
Zero.
So it's like,
So that's H.
so then multiply that.
So.
If they move this to the denominator, and then I think they use that in the denominator to reduce the numerator.
Okay.
So now, the next thing you do is
I do seconds I get here, so I don't remember exactly what like.
Yeah, that doesn't make sense. You don't take, the derivative of a constant is 0 anyway, so.
How is it maybe
And so it gives you a
Okay, well, the derivative is 4x plus 1, which is 4.
I wouldn't use that, I just did that, I just gave you
Are you following?
Okay, so if I'm just looking at this, the derivative, power down, multiplied by 1,
Mhm.
it came back and multiplied by 2. I'm with you here.
So,
Mhm.
you
Okay.
find H
And
and
then I
X, it gives you.
multiply out the.
No, you can't do that.
So I just
Because you're
find
doing
that.
multiplication before
Oh, no, I
exponents.
didn't, I just said that.
Okay, well, exponents don't work that way. You don't get to put this on this and then this on this. It's like when you square something. X plus 5 squared isn't
It
x
gives you
squared plus
here,
1
so
plus
H
5. X plus 5 times x plus 5.
times 3 equals
So how do I do that?
I would take this times 4 divided by 2. You could reduce
Just write down
those.
all your stuff.
Mhm.
You can move this to your denominator.
So,
So I wouldn't like distribute it.
just follow.
You can't distribute it anyway, put that exponent there. No, you're almost done.
I'm
This,
confused.
you took the derivative correctly, now to simplify. Move this to your denominator to make it have a positive exponent. Write it as one big fraction.
Like, what would it
You can change these from 1 to the 1. So change the G of X to each.
Now just move this to the denominator to make it have a positive exponent. Only do that.
So would it just be one?
I don't see it in the denominator.
So now, first thing you do is move H back.
But that doesn't look like your bags. Here's your denominator. You're putting it in the
So
denominator.
just rewrite the whole thing to simplify H back. Or 2. Yeah. And then rewrite H back.
See, I still don't know what's in there. Multiply these two things together. Don't worry about this at all. You got something times something, right? It is one fraction. What is 1/2 times 40? Okay,
3 times negative
so
3 is.
show me a 2 in your answer. This is currently in the numerator with a negative exponent. Move it to the denominator to make it have a positive exponent. That's not your denominator. That's still your numerator.
Yeah,
You could just use the same.
That's not, this is not your denominator though. So why did you are putting it on the top?
It's just changing what it's looking.
You want me to put it? I thought if it's positive or if it's negative, it needs to go to the denominator and make it positive.
Yes, that's it, but that's not what you're writing down. You're not,
Change the H's to G's.
you're not writing it in the denominator. You say you are, but you're not. Tell me what you had. You had 1, something like this. Is that, okay, what was this?
4x plus 1.
This, leave this alone. You can even leave this alone. This needs to move to your denominator so that it can be to the positive 1/2. But it's got to, I keep saying that, but you keep writing it in your numerator. You're not.
I didn't know what it was. Never mind. It's fine.
Then cancel your 2 and your 4 and make it a 2, and then it should look like one of your answers.
It's even. Is it nothing? It's something for sure. No, 23. The 2 part, it gives you this. You don't even need the extra ones. Okay. I'm dividing it here. And it gives you right there. So the journal of G
Is there more to beta means today?
No idea.
and minus a negative 2.
I'm not the Mu Alpha Theta sponsor. But you would have had to have been signed up yesterday anyway.
Do what?
I said you would have had to have been signed up yesterday anyway.
Yes, that's very sad. That's why I don't like it.
Well, I'm not a fan of it either, but something like clubs, you should know about it, right? You got the homework turned in your classroom?
Oh, yeah.
Again, when y'all get to the second one with tables, if you're not trying to work it out the way that I have frozen on the board, it's gonna be much harder than necessary. It's the same chain rule, it's just written in math symbols, which is a little bit easier to compute.
Just copy that one on the ground. Just read it right.
Doing okay? Get that finished? Go front again? Yes. And if it's just clicking a little bit quicker for you guys, and you're done with both Khan Academies, and you turned in the homework that you need to turn in the Google Classroom, that's all I've got for you today. So you're welcome to work quietly on something for another class. And if you're not there, that's fine, because you still have almost 30 minutes. There's still plenty of time. Which one are you trying? The mixed quiz. Yeah.
So what's the journey? Does it say that on the table? I thought it was also too, no? Yeah. Definitely messed up somewhere. Oh, it must have gone with you, but you wrote it like that.
So, let's just
Yeah.
show it.
So, use the formula, right? So first you have to do g of x. It gives you the x value. What's the x value it gives you?
7.
So it would be g of 7. What's the g of 7? Right over there. On the table. Let me
Number it gave me is 1.
oh, it gave you 1.
X equals 1.
If x equals 1, then you take the g of 1. Look on the table. What does it say g of 1 is equal to? The first and the formula is you want g of x, right? It gives you x. X equals 1. So g of 1, so x value of 1 under g of x is 0. Right? The next thing, you have to plug in the derivative of 0. The part is 0. So the derivative is 0. This means and then you have to multiply that by g value of x. So it gives you x, so g value of 1 is negative 2. So then you can negative 6. You just have to follow that formula there. Did you finish it?
Yeah.
So then, okay. You figured out what to do on those? Report? You done? Get the homework through
So, okay, finish your work.
I don't post anything to Google Classroom. I try to put it all in the classroom as far as handouts. The main thing is you need to watch the classroom. You never find that out.
Yeah,
So that's gonna be
For the test.
reminding you to turn stuff in, reminding you about the test that's coming up, the overview, what's due. You really need to watch out for that. But yes, I do try to put on the website
I've
things where you
tried
can
to
download this stuff and print it if you have a printer at home.
Negative 3 times g prime of
If you
x.
don't,
It's like the same thing but with values.
well,
And like
my 8A class is a day ahead right now, so I have to have my stuff ready for the third period. So, like, if you know you're gonna miss Thursday, you could stop by tomorrow and you might be able to get that out. That would be the only other thing that might be easier for you.
Actually, best practice test, although it's, if you go to Khan Academy,
We don't want to, do practice tests and we don't wanna make y'all think this is what the test is gonna look like, because it's not. But if you go to,
just like the Billboard,
yeah. Sometimes it has a few different things mixed in, which is why it's not perfect. But it should, so unit 2. What is your school thing you're missing for?
Oh, the TXL thing. I gotta figure that out probably. But yeah, and then that.
So once a month, can you do this?
Yeah.
What about the assignment? Did you guys have any good questions?
Yeah.
I think so.
Yeah, I finished that, but I just have dog crew. Is there a spot to turn in 26?
I just haven't asked for it yet.
Okay.
I try to get points for most things, but like right now, 26 is way less important than the other stuff. So I might still ask for it, so keep it in mind here, but
Okay.
You don't have to worry about it yet. It pretty much tells you what numbers to pull from the table. It's kind of uncomfortable the first time you use it.
It should be that.
Does that make a difference? Did you use an app for those tables? Girls, we got one.
Not at the moment.
Have you tried any of the table questions yet?
I get confusing when it changes the letters, cause like I'm on a roll and then it changes the.
What I would do, what makes me feel way more comfortable is write that down on your paper.
Okay.
And then if it's different letters, I just change them right away.
Okay.
Like F was the outside for me, so I changed those to Ds. G was the inside, so those are H, and then I just changed them right away. I agree that is a extra. Okay, so for the table questions, write that down, it's up on the board. That's the chain rule, just in math notation. Okay, so if we want the derivative at -1, so everywhere there's an x, plug in a -1, we would just copy that same one down, but replace your x's with -1. Okay, so, this one is supposed to be prime.
Make this easier, change the.
Okay, so this you should get from the graph. What is g at -1? Okay, so cross that out and put a 1. Let me see. Okay, what is f prime at 1? Okay, so all of that goes to 7. And then that gets multiplied by this. Yep.
Yeah.
Not yet, no. I'm asking for the other one. When I was telling them, I try to get points for most things that we do. I can't get everything, so I might still ask for it before the test, but it's a little less important than the part of the question, so.
You'll still have about 17 minutes, so if you're still struggling with the tables, you might need to ask for some help. At least help me get you on the right track before you leave. If you don't finish the Khan Academy, you can do them for homework, but they've got to be done before the start of next class.
did these, I just didn't know how they found them. It's like yeah.
Yes. Sure. Thank you. My signature down. You didn't make it very far in the day.
I don't have any more important classes.
Well, of course, this is the only important class.
Yeah.
Okay, you're down to about 8 minutes. So, again, you're running out of chances to ask for help. Please bring it up or call me over it. That's fine. How many IDs do you have?
4? I mean, if they're gonna make me get one, I'm gonna wear it.
You don't have to wear them all at the same time.
fast you have to move these inwards.
I don't know. Probably not linear, but probably close to linear. I don't know. You could probably Google search and get some tips from people, but I kind of like to figure it out on my own. Alright guys, we're down to about 3 minutes, so time to find a stopping place. You borrowed a calculator, please bring that back. If you did not get 100 on both of those Khan Academy assignments, you need to keep with it and do that before Thursday. And then one of your assignments from last class, not today, is going to be doing Google Classroom before I see you all on Thursday. So please add that to your list of things to do. Or just do it now. Or do it right away in advisory so you don't forget. Don't you guys also get an email when there's assignments due in Google Classroom?
I just get a notification on the phone. I don't know.
Does it notify you when it's like almost late or when it's...
Yeah, it notifies you like 2 to 3 days before.
Okay.
It's like a night before it's due. Just like it's due at midnight.
It'll notify you multiple times.
Okay, good. That's what I thought, but some of y'all need to check your school email more than